Good evening, everyone. It's about 9:20 on the evening of the 15th. So if you have done your best on the chapter review and still have no clue what's going on, you checked your notes, you looked through all your vocab words, that's what this is for. I want to make it clear, you guys, that this is not meant as a way to supplement the past 3 weeks of work and lecture and activities and everything we do in class, because you're not going to learn it the same. Okay. Anyway, if this is what you got, let's go with it. So, number one, so the interior angle sum for each polygon. So the equation we use is n minus 2 times 180. The n minus 2 is the number of triangles in each polygon. We know that each triangle has internal degrees of 180. So we figure out the number of triangles per polygon, multiply it by 180, and that gives us the interior angle sum for each polygon. So, sorry, my daughter's washing the dishes, and that's like a once in a blue moon thing, so I'm not going to interrupt her to make her stop. Okay. So notice what we did is we started at one vertex and kind of fanned out to all the non-consecutive vertices. And this is a nonagon. It's got 9 sides, and we end up with 7 triangles. Now that goes through. So that's where that formula comes from. So we go 9 minus 2 times 180. 7 times 180 gives us 1,260 degrees. So now that we've done that, our next step is to go to number 2. When I count the sides, we get 11. So just plug that into our equation. 11 minus 2 times 180. 9 times 180 gives us 1,620. Now, that is a quadrilateral. We know that quadrilaterals all add up to 360, but even if we didn't, we go 4 minus 2 times 180. That gives us 2 times 180, or 360. Number 4, we have an octagon. That means 8 sides. Let's go 8 minus 2 times 180. 6 times 180 gives us 1,080. So for 5, 6, 7, 8, I'm actually just going to sit there and kind of skip ahead. Really, the only question is, what do hept and hexagon mean? Despite this absolutely being in the notes, I'll go over it anyway. Heptagon is 7, hexagon is 6. Again, if you want to write them down, triangle, 3. Quadrilateral, 4. Pentagon, 5. Hexagon, 6. Heptagon, 7. Octagon, 8. Nonagon, 9. Decagon, 10. And as we went over, there's no shape called a Bakugan. Okay. So those are the answers for 5, 6, 7, 8. That gives us 900, 720, 2700, and 1620. Moving on. So for 9 through 14, we know that all of the exterior angles have to equal 360. You remember Andy angles kind of trip around the triangle, regardless of which direction he went. When he ended up at the starting point, he had traveled 360 degrees. So we know that all of the exterior angles have to add up to 360. As you can see, this is a regular, as it says regular right there, polygon. That means all of the angles and all of the sides are the same. So a regular polygon is both equilateral, all the sides are the same, and equiangular. All the angles are the same. So we just go 360 divided by the number of sides, and that gives us our answer. So for 9, we go 360 divided by 10. 36. Heptagon is 7. 360 divided by 7. 51.4. 360 divided by 25. 14.4. 360 divided by 18. 20. Hey, look at that. I answered before the writing did. I'm magical. 360 divided by 5 equals 72. And 360 divided by 22. That I don't know off the top of my head because it's 16.4. And let's be honest, if I knew 16.4 off the top of my head, that'd be weird. Okay, so now 15 through 20. It's asking for one interior angle of each regular polygon. Now, keep in mind that when we did n minus 2 times 180, that was the sum of all of the angles, okay? So that's the number of triangles times 180. But we don't want the sum of the angles, we want 1. So we're going to take that, remember, an n is the number of sides. It's an n-gon. Read your notes, people. I cannot stress how important it is. I do not make you take notes just to keep your hands busy. It actually has a reason. I mean, keeping your hands busy is part of it, but anyway. n minus 2 times 180 over n. So that's going to give us the total angles in the polygon, and then we divide it by the number of angles. And since it's a regular polygon, again, see, regular right there, then we know that that is going to give us each individual angle. So for 23 gon, the 23 minus 2 times 180. Now, I am a huge fan of writing out the entire equation first. Now, a lot of you guys are going to want to go, oh, I can do 23 minus 2 in my head. That's 21. But then what happens is you go 21 times 180, and then you end up dividing by 23, okay? But some people will make the mistake of dividing by 21, because you've got that 21 times 180, so we'll divide by 21. Well, that's just going to give you 180. So write it all the way out, then go through. So that gives you 164.3. 20 minus 2 times 180 over 22. Or over 20. Sorry, so that gives me 18 times 180 over 20, 162. 15 minus 2 times 180 over 15. That's 13 times 180 over 15, or 156. 18 minus 2, you get the picture. Okay. So those are the remaining answers. 18, 160, 19, 161.1, and 20, 140. If you got something different, please come see me before the test. Okay. Or email me. If you're watching this and you're like, hey, I don't care what time it is. I mean, if I'm asleep, I won't answer you. But I will answer you first thing when I wake up. So there's that. So moving on. Page 3. Okay. Now, these, a lot of people were freaking out with, but so much of it has to do with understanding the rules of parallelograms. So go back to your notes, okay? And parallelograms are defined as a quadrilateral with two sets of parallel lines. So top, bottom, left, right, parallel. Because they're parallel, we then get 4 separate facts out of that. And these are those facts. Not only are the opposite sides parallel, they are congruent. That's 1. The diagonals bisect each other. That is 2. Consecutive angles are supplementary. 3. And opposite angles are congruent. That's 4. Okay, this is also something that we went over on the day when we did the whole Venn diagram thing. So, what do we do here? Well, we look at Q and R. We know that the measure of angle Q plus the measure of angle R is going to be 180. And the reason for that is they are consecutive angles in a parallelogram. How do we know it's a parallelogram? Because it says so. So we know the measure of angle Q is 14x minus 4. We know the measure of angle R is 33 plus 4x plus 7. And when we add all that up together, we get 180. 14x plus 4x is 18x. All the constants go together to form 36. Start moving stuff around, we get 18x equals 144. We're going to divide out, and we get x equals 8. Now we have to find the measure of angle Q, so we're going to take that 8, plug it in, so we get 14 times 8 minus 4. It's going to give us 112 minus 4, or 108 degrees. 22, same thing. We have two consecutive angles, so we know that they are going to be supplementary. Now keep in mind that top angle, that angle V, okay, that angle V is made up of two smaller angles, so we need to make sure that we're adding both of them into the equation. It's not enough to go 10x minus 9 plus 45, because that 45 degree angle is just this one right here. These two right here don't have anything to do with each other. These two do, okay? So it's not just V, it's not just U and UVT, it's U and UVW, okay? So when we plug all that in, we end up with x equals 9. Now here, I'm going to hit the jump forward button, not what I want to do. X equals 9. See? Winding back time. It's awesome. Okay, now we're asked to find W, okay? We don't have W. We don't know anything about W, but we do know that it's opposite from U. See? The arrow says it's opposite from U. We know that because it is a parallelogram, opposite angles are congruent, so we know that W is also 10x minus 9. Enter the fanfare. So we have 10 times 9 minus 9 equals 90 minus 9, or 81. So the measure of angle W is 81. Same exact process for Coco, no. Mina? Hold on, guys. Let me hit pause. I'll be right back. Sorry about that. My wife was in bed, and the dog wanted to go in the room, and I didn't want to get up. So I had my daughter do it. Okay. Moving on. Okay. These are tricky. So we have 4 problems like this. We have 27, 28. Did I do that right?
She weighs 800 pounds.
She does not weigh 800 tons. Maybe 600. So 25, 26, 27, 28, they're all the same. Now, for some reason, I end up skipping 25, 26, but it's okay. I will go back to it. So, now, if you were paying attention to the previous slides, then you'll know that not only are the opposite angles supplementary, excuse me, I had to drink some water, but they are also, because it's a parallelogram, the diagonals bisect each other. So that means that WM and MY are congruent. So what bisect means cut in half. So what we're going to do is we know then that WM times 2 equals WY. So WM is half, so we know that half times 2 equals the whole. So once we know that 2WM equals WY, let's go ahead and substitute out. So instead of WM, we put 2x plus 9 equals 2x plus 18. It's going to give us 4x plus 18 equals 2x plus 18. We're going to subtract 2x from both sides, subtract 18 from both sides, and we get x equals 0. So this means that WM equals 9 and WY equals 18. And that makes sense. 9 is half of 18. So it works. Now look at over here on 28. Okay? Notice that, again, CN and NE are going to be congruent. But unlike 27, where they give you the half and the whole, here they give you the 2 halves. They're being tricky. So what I do is just set these equal to each other. Since we know that half number 1 is equal to half number 2, we just set CN equal to NE. So what I did here is I got 4 equals 2x, or x equals 2. This is wrong, but I still want to show you what I did, just so you know that it's how you catch yourself. So I'm told to find CN. So I find CN, and I get CN equals 11. So I'm like, okay, Now, if I don't go back and check my work, I end up getting this wrong. So I'm going to go back and check my work. I know that Cn is 11, which means that Ne should also be 11. But if I plug a 2 in there, I get 5 times 2 minus 1, or 10 minus 1. That gives me 9. Notice, 9 and 11 are not equal to each other. So I did something wrong. Go back, check my work, and I realized what I did was I subtracted 1. Okay, so that's how I got 4 equals 2x. I subtracted 1 from both sides, subtracted 3x from both sides. When really what I should have done, see, it's wrong. I really should have added 1 and gotten 6 equals 2x. That's going to give me x equals 3. Cn is 3 times 3 plus 5. That's 9 plus 5, or 14. Check the other one, 5 times 3 minus 1. That gives me 15 minus 1, or also 14. See, that checks out. I had the interesting, was grading a test for the 8th graders the other day. And so a lot of the work, this one test, like she went back and she checked every single answer, except for 2. And of course, those were the 2 she got wrong. So go back, check your answers, make sure you did it right. If it doesn't match up, look back over your work. Try and figure out what you did, or at the very worst, just redo the problem. That'll give you a set of fresh eyes. Then you can look at what you did do and then compare and contrast that with what you had already done. Okay. This is where kind of all the wheels fell off for a lot of people. So 29 on, we are dealing with either parallelograms, triangles, or quadrilaterals. Now, each one of these is going to be different. 29, we're being asked to graph the triangle and tell us whether it is scaling, that means no sides are the same. Isosceles, that means 2 sides are the same. Or equilateral, that means all 3 sides are the same. So we're going to go ahead and we're going to do that. Now what we want to do in trying to figure out, we need to run the distance formula 3 times. The distance formula is going up because we have 3 legs of a triangle, AB, BC, AC. So what I'm going to do really quickly is over on the left hand side, I'm just going to write out all of my points. I'm going to label them x1, y1, x2, y2. So for AB, I write out what point A is, -3, -2. I write out what point B is, 3, -2. I then attach them, x1, y1, x2, y2. And then I go and do the same for the next one. Okay? So, what we do now that we have them all labeled as x1, y1, x2, y2 for AB, we simply plug that in. We get 3 plus 3 squared plus 2, -2 plus 2 squared. That gives me 6 squared, or AB equals 6. So notice what I did there. Okay, so I took a couple shortcuts. First of all, I went -2 plus 2 is 0, 0 squared is 0, instead of actually writing it out. The other thing is, when I got to 6, the square root of 6 squared, in my head I went, hold on a second. Squares and square roots are inverse operations. They cancel each other out. So because I had a square root of 6 squared, that basically turns into the question of what number, when you times it by itself, equals 6 times 6. Well, clearly that's 6. So I just cancel them out, and I get AB equals 6. Run the process for the other two, BC. Now notice here I end up with a square root of 34. Okay, so because I have the square root of 34 there, I know for a fact that we are not dealing with an equilateral triangle. Still need to run the third side, because if it is 6 or 34, then it is an isosceles triangle. If it is neither 6 nor 34, then it is a scaling triangle. So let's see what it is. Drum roll, please. Like, the excitement killing me. I mean, except that I've already done this several times today, so I know exactly what the answer is going to be. Now, make sure you're keeping track of your signs when you're doing this. You don't want to end up with dropping a negative or something like that. Okay, where'd I go? There we are. So, the other diagonal, or the other leg of the triangle is square root of 34, radical 34. So we had two sides that are the same. It's an isosceles triangle. Now, 30, totally cheat. Okay. This is a right triangle. A right triangle cannot be an equilateral triangle. Ever. The reason for that is an equilateral triangle is also equiangular. So all equilateral triangles have interior angles of 30 or of 60, 60, 60. That is an absolute rule. Can't break it. What do we know a right triangle to have? A 90-degree angle. Because if it didn't have a 90-degree angle, it wouldn't be a right triangle. So we know it's not equilateral. So now we really just need to check to see if it's isosceles. Now again, because of the Pythagorean theorem, only the two legs can be similar. The hypotenuse can't. Now, the creators of this problem were kind enough to sit there and give us a vertical line and a horizontal line. Why is that kind? Because we don't need to run the distance formula, though we could and get the same answer. We just need to count boxes. So that top leg, A to B is 5, B to C is 4. Notice that none of the sides are the same. 5, 4, and the square root of 41. So it is a scaling triangle. Okay. So, so here what I did was I did it with, and this was on the bell work, D is actually -1 instead of 1. If it was -1, 1, it would have ended up being a trapezoid. Now, determine whether the parallelogram is a rhombus, rectangle, square. Okay, guys, this is, like, super, super important. This is, like, key, okay? Up on the board, currently, and I'm not taking it down before the test, is the hierarchy of quadrilaterals. Now, the hierarchy of quadrilaterals isn't of itself all that important. But what it does do is it sets up a structure for us to look at and a way to talk about kind of ever increasing specificity in the work we do. So when we are looking at these problems, it's important to know what it is you're asking and how you figure that out. All parallelograms have the same set of rules that apply to them. If you are a rectangle, there are two extra things about you. It is equiangular, and it is the diagonals are congruent. So we have equal angular and congruent diagonals. If you're a rhombus, it is equilateral, meaning all the sides are the same. Don't care about the angles. And finally, we have the square, which is both a rhombus and a rectangle. Every single square is a rhombus. Every single square is also a rectangle. We just have a slightly more specific name for it. So, 31 and 32. I did not give you a graph, but if you want to, you can just sketch it out on a piece of paper. Because I can actually just kind of erase back and forth, I used this in front of me. So what I notice is that when I graph this, I have two vertical lines and two horizontal lines. Now, horizontal lines and vertical lines are, by definition, perpendicular to each other. So we don't have to run anything with the distance formula on this one we can just sit there and look at it and go, okay, I know that top line is perpendicular to the side line. And that's it. So we know it is a rectangle. Now, I can look at it and pretty much say that it is not a rhombus. But that's not enough. As I said on Wednesday, I want to make sure that you guys are actually sitting there and learning and using the vocab. So what I'm doing right here now is just running the distance formula for one of the diagonals anyway. Just to show you that even had we done it this way, we'd still be in the same position. So we get the square root of 17. And notice how both of the diagonals had square root of 17. That means you did it right. Moving on to number 32. So I'm graphing it up there. So this is what it looks like. Now notice when I look at my diagonals. Okay, so rhombus, diagonals are perpendicular. So rhombus diagonals are perpendicular. Rectangles diagonals are congruent. If it is both a rectangle and a rhombus, it is a square. So notice here we're looking at it's a rhombus. How do we know it's a rhombus? Because we have the diagonals are vertical and horizontal, and vertical lines and horizontal lines are always perpendicular. So because we have this quadrilateral with perpendicular diagonals, then it is a rhombus. So now we need to figure out whether or not it is a rectangle, because if it's a rhombus and a rectangle, it's a square. Now again, because they were kind enough to give us vertical and horizontal lines, we can just count them. So that green diagonal, 4. Blue diagonal, 4. That means that we're good to go. Okay. So now we have our last couple. Now this is graph the following points and give them a specific name for each quadrilateral. So you guys know how to graph, okay? So what I want to do first is I want to figure out whether or not it's a parallelogram. Now it looks like a parallelogram. It's probably a parallelogram, but I want to know on each and every one of your papers whether or not you thought it was a parallelogram. How do I do that? Well, what's the definition of a parallelogram? Definition of parallelogram is an object or a quadrilateral with two sets of parallel sides. Since we are geometry students, we know that the manner in which we detect that is through the use of slope. So what I'm going to do is I'm going to quick run the slope 4 times. Okay, top, bottom, left, right. Now, if all of those match up, then we'll have a parallelogram. So here we have the top and the bottom having slopes of -3/4, and the so we know it's a parallelogram because the bottom one's 3/4. So we know it's a parallelogram. Now we need to figure out whether or not it is a rhombus. So it can either be a rhombus, a rectangle, or it can be both. So we know that it's not a square. How do we know it's not a square? Because we're looking at it, we know it's not a rectangle. How do we know it's not a rectangle? Because when we look and compare the slopes of the sides, they're not negative reciprocals of each other. Slopes of perpendicular slopes are negative reciprocals. Here we don't have negative reciprocals, no slopes. So what we need to do is we need to find the slope of the diagonals, and the slope of the diagonals will determine whether or not it's a rhombus. Remember, a rhombus has perpendicular diagonals. So if we can find in someone's dressing room, I have no clue what just happened. Okay, so if we, for some reason, I think I slipped off when I was talking about shoes or something, like missing shoes in dressing rooms. Anyway, what we're dealing with is if we can show that the diagonals are perpendicular, then the sides are all the same. So we're going to go 0 plus 2 over negative 2 plus 6. That gives us 2/4 or 1/2. Now, the opposite reciprocal of this slope is negative 2 over 1. I screwed that up. So now I'm going to find the slope of the red diagonal. And if it is negative 2 over 1, then we have ourselves a rhombus. Yay! It's a rhombus. Okay, so on to 34. So we're going to graph out 34. Now again, if I had to look at this, it's probably a rectangle. Is that enough? Absolutely not. I want data. I want work shown. I want facts. I don't want, it looks like it has to be a rectangle. That's not enough. So what we're going to start off with is figure out whether or not it is in fact a parallelogram. Take the slopes of all the sides. So that top side has a slope of negative 2/3. Bottom, negative 2/3. Left, 8/3. Right, 8/3. So we have agreement between all of those. So we know that it is a parallelogram because opposite sides are parallel. So now what we really need to do is we need to figure out whether it is a rhombus, a rectangle, or both, and it's a square. Well, we're looking at the slopes. We see the slopes are negative 2/3 and 8/3. Okay, those are not perpendicular slopes. Not only that, look at it. Both of these slopes are positive. You can't have both. So they're both positive, and because the slopes of perpendicular lines are negative reciprocals of each other, one is going to be positive, one's going to be negative. So what I want to do now is, clearly that's talking about slopes. So I want to draw these out, and what I'm going to do is I'm going to actually work on the distance formula here. Because how we tell whether or not something is a rectangle, is to make sure that their diagonals are congruent. So we take negative 2, negative 4 squared, plus 0 minus 6 squared. That gives us 36 plus 36 or square root of 72. That gives me 6 radical 2. So now we want to do it with the other one. And it turns out that they are not equal. I'm not sure what happened to my red diagonal. We have 1, 8, and we have 1, negative 2. So that distance right there is 10. Because to go from 8 to negative 2 is 10. So we know that the red one has a distance of 10, or length of 10. And we know that the purple one has a distance of 6 radical 2. That is not congruent. So, moving on. Again, looks like a rectangle, but so did the other one. The other one turned out not to be a rectangle, so we want to be careful here. We'll plot our points, find the slopes of all 4 sides. Now notice here, when I find the slopes of all 4 sides, I end up with negative 3/5 and 5/3. Negative 3/5 and 5/3 are, in fact, so negative 3/5 flipped over, made positive 5/3. So we know that it is at least a rectangle. How do we know that? Again, because all of the sides meet at 90-degree angles. That means each angle inside the shape is 90 degrees. Which means it is equiangular. Which means that it is a rectangle. So what we need to do is figure out whether or not it's a rhombus. It doesn't look like a rhombus, but we should still run through the again, I'm sorry, I'm just kind of not able to keep track of thought. So, again, we have two lines with positive slopes, so we could probably go with that it's just a rectangle. But it helps to check. Again, I want actual data, I want actual work shown, not, hey, I got, it looked square, it looked rectangle, it looked like a rhombus, and so on and so forth. So here we end up with the square root of 13 and 8 over 11. I don't know. So it's just a rectangle. Now, finally, same general idea. So we write this up and figure out our slopes. That's a bit far. Slopes, negative 1/3, 5, negative 1/3, 5. Okay, so we know it's a parallelogram because the opposite sides have the same slope. That means they're parallel. We know that they are not perpendicular, so it's not a rectangle. We can then sit there and sketch out the diagonals and run the distance formula for each one, because we know that if they are perpendicular, that it's good luck. Well, it's a rhombus. I don't know why I say good luck. Anyway, so here we're looking at negative 1/3. That's the slope of the red line. So in order to be more competitive with that, you'd need in order to be perpendicular, you would need a positive 1/3 slope. Take the 3 over 1, flip it upside down, that gives you 1/3, and then it's in. So what we need to do is run the other one, the blue diagonal, see whether or not that has a slope of 1/3. If it has a slope of 1/3, this is a rhombus. If it has anything else, it is just a parallelogram. And so we go 1 minus 3 over 0 minus 4 equals negative 2 over, unless it's a 6, we're not, so we're not going to hit 1/3. It's going to be close. We get negative 1/2 instead of positive 1/3. Yeah. So it's a parallelogram. We're done. Sorry about the incoherency. It is currently 10:01, and I shall see you guys on the morrow.